Okay, good afternoon. I'm Pedro Rosa, and I will be the guy delivering this masterclass, Unleashing the Power of IoT. If you want or have questions during the session, you can post it on Twitter using this hashtag, Microsoft GWS, and you can put questions and I will answer them as soon as I can. Again, it's on Twitter, so you just have to put them there. Regarding me, I'm Pedro Rosa. Some of you probably know me, but for those that don't, I worked in several companies before the company that I have now. I worked in Microsoft, in CGI previously, in General Martins. It's a Portuguese company, a retailer company. And I'm also the co-founder of the IoT Portugal community that now has more than 600 members. In fact, today I was looking at the numbers, we have more than 700 people. So if you want, you can join us on Facebook and try to discuss there things regarding IoT. Main Hub is the company that I'm one of the founders and is an incubator regarding IoT and app development. So everybody that wants to be in a place where they can share knowledge and exchange information, Main Hub is a very cool place to be. Also, we are the organizers of the IoT Summit, and last year we had more than 600 people registered with 30 startups in the showroom and 16 technical sessions. Regarding the agenda, we are dividing our session in several topics. The first one, a definition of Internet of Things, just for everybody that is on this session to have the clear understanding what we're talking about. Then something about the numbers, where we are now, where we're going to be in a couple of years. Then we're going to spend some time on the development stages of an IoT solution, starting from the idea until the production and deploying on customers that want to use it. And after that, we are going to see the challenges that the IoT development has now. Like, for instance, how do we get power, how do we get communications, how do we handle the data? And I will give you some examples of things that you can do or things where you can look information. In the middle of this, we'll have some demos. I will show you two different demos on things that you can do with two platforms for rapid prototyping. And I hope you understand that, of course, I'm showing you little bit examples, but you can do a lot more than we're going to show you now. And starting for the first part, the definition, what is the Internet of Things? For some people, that is a question that most people have. Why? Because everybody talks about it, but nobody tells you exactly what they think. Some people say it's like Las Vegas, so it's a very good thing to be on, to develop things and to put them on the market. Usually these guys are the guys that are doing something like a startup or a medium company. But the definition is anything that is connected on internet. So anything that can get information, interact with objects, get information and send it to the cloud or to another device, it's the Internet of Things. So, like a mobile phone can be also a device in Internet of Things. A tablet can be a device on Internet of Things. Not only the things that we develop now are Internet of Things. You can have several other things that are also connected. And starting from that, where are we now regarding numbers? Well, as you know, the mobile numbers have been increasing significantly every year. So we have several million, in fact, billion of devices connected on the internet. But when we started a couple of years ago discussing connecting more things like sensors, like fridges, like TVs, and a lot of other stuff, we start to see the numbers increasing very rapidly. As you can see, as in 2014 we had around 6 billion devices connected. We expect around 2017 to have around 13 billion, so it's more than double of the devices in 3 years. So it's a very rapid increase, and we expect in 2020 to have 27 billion. So again, in 3 years we double the numbers, and of course this doubling means that the growth is immense, and it has a lot of people connecting new devices, because of course We cannot have more than one mobile phone or two. After that, it's impossible to have three, or unlikely at least. So the other devices that are connected are from completely different things. But this gets me to a very important point, because now we can call niches some things that, some apps that are only for some devices. But as the devices increase like this, the niches will be from millions of devices. So you have like a niche that could be a million of customers, and it makes valuable to develop stuff for that kind of niche. So as you can see, 6 billion to 27 billion in 2020. If you look at the markets that we are going to develop new stuff, you can see that we have identified five different markets that you can look at. Verticals: home, of course, will be probably the place where you're going to be appearing new devices, and a lot of new devices. Then we have cities, like smart cities, and in Portugal, for instance, we have a great discussion about smart cities and how to improve the city, to get information from the city and to try to understand what to do. Buildings, for instance, internet infrastructure, like saving energy, reading everything that happens inside the building. And then you have health and transport, like mobility and health, everything that you can do with your health, like everything that's connected to running, to sports, or even to measure your heartbeat, for instance, to understand exactly where you are and if you don't have any problems. So there are a lot of devices appearing, and of course there's a lot of devices. This means a lot of money, and the money is going to be divided in three different things. The guys that do the hardware, enabled on hardware, the guys that provide the network service, and the guys that provide the managed services. For instance, the guys that have the cloud and going to give the opportunity to use the cloud in order to store and to analyze all the data that the sensors, that the devices on the Internet of Things can provide. So this is not only an opportunity for the people that are going to do hardware. This is an opportunity for all the business to increase their sales. As you can see, there's a lot of difference, like almost 10 times more from 2014 to 2020. So 10 times more in the growth of the industry, it's a lot. That's why this is so important for everybody. Okay, so why IoT now? Well, because it's in a tipping point. A couple of years ago, if you want to develop something like we did in your office, for instance, to control the lighting, to be able to turn off and turn on every light using a common browser, for instance, you spend a lot of money. And if you want to communicate further to another office, you will spend a lot of money in communications. And if you try to develop it, you use very hard to use interfaces that were very difficult to program on. And the market was not really understanding the benefits. They took a long time to understand after the apps that they can use more of the surroundings they have, and that's why the customers are only realizing this now. And because of the new things, new use scenarios appeared. That's why IoT is now so much in the spotlight, because everything is more or less connected and at the right place at the right time to be able to do things. And as comparison, you can get to the app thing. A couple of years ago, we started the apps, and the reason why the apps appeared, everything developed for the iPhones and the Androids and the Windows Phone, was it was easy to develop, the market was ready, easy to distribute because of the stores, and it enabled to create enduring relations. So we can say that things are the new apps, because they are easy to develop now. You can have several IDEs that are very fast to produce code, as you can see in the demo that I'm going to show you. The market is ready. It's easy to distribute. Well, it's not so easy as apps, because you have the physical thing, you have to distribute it. I'm going to talk about it a little bit further. And you can create enduring relations. For instance, one of the things that I have here, this Nest, is one of the most used sensors in order to understand what is the temperature inside my house, and then to connect to the air conditioning and try to put it exactly as I want. So he has included artificial intelligence to understand what are the good things for me and try to adjust it. A couple of years ago, this is very difficult, if not impossible to do. Of course, also the market and the venture capitalists are looking at this kind of startups. A couple of years ago, I was discussing it with a venture capitalist, and he was saying to me, well, I don't really care about IoT startups. Why? Well, because they take too long to develop. They take 5 years to develop. They take a lot more than an app to build. They have to prototype. They have to do things. And with an app, it's easier, so it's cheaper, so it's faster. In a matter of fact, it is. But if you look at how in 2015, how is divided the venture capitalists that are interested on this kind of market, you will see a lot of Intel, Qualcomm, Cisco, so a lot of companies that are interested on this kind of investment on this kind of companies. And there are a lot of companies, as you can see on this slide, that are interested and already bought, or they are going to be bought really soon. Okay, and regarding hardware, so I want to develop my own device. What is the steps that I need to take? So if you look at IoT product development and you try to understand exactly what happens, you can look at it on the 5 different stages. The first one, the kickoff and ideation, is the step where, well, you have the idea. You are starting to look at something and you say, well, I like this. Maybe I can do a little bit different and better and put the product outside. After that, you will get the IoT concept development. And this is what we usually call proof of concept. We try to do something glued with, I don't know, maybe the simplest things just to prove it works. And then you try to see if it works, and if it works, you try to understand if the market needs it exactly as you have it developed, or you change it until you have something that you can put outside. Then you have pre-production. The pre-production is after the proof of concept, and where you try to create some devices, not exactly the number that you need, but some devices as a beta testing, and you put it and you sell it through, for instance, crowdfunding. After that, you have production, and production is the real deal. You start to product a lot, usually using a manufacturer that you find in China, and then you try to put it on the market and sell it. After that, you have the last stage. Everything is running, you are selling it, and you have to maintain it, because you have to do several things in order to make your product better and to have your product with all the fixes and the bugs that you need, all the firmware corrected, etc. So, if you go into these steps in more detail, you have the kickoff and ideation. It's inventing the concept, understanding the ecosystem in which it operates, like a business plan, understanding exactly who are your customers and what kind of development you need to do. Then you define the required behaviors and patterns. And in this time, there are two good things that you should look. First, you should try to find your partners as soon as possible. So if it's possible, already here. Why? Because your device is not only a hardware thing. You will need code. So you will need someone like an app developer or several app developers to develop on the online platform, or even developing the firmware for the device. So you really need to find those people quickly in order to have them on board. Another thing that you should try to understand is the manufacturers that you have, the possibilities that you have. Usually now everybody tries to look for local suppliers for the first prototype and the first betas that you want to deliver, and then you choose probably on China another manufacturer for the production because of costs, of course. Usually this kickoff and ideation, it takes more or less like 1 to 2 months. It depends on the time that you have to invest on it. Then you have the IoT concept development. Here, you specify the requirements, you order your dev kits in order to try to understand exactly what you can develop on IoT on the device that you want. And then the app developer will start to program or the firmware or the web or the mobile application. It depends on the IoT device that you are developing. The IoT hardware kit can have a lot of different manufacturers. In fact, I've chosen these 6 that we have here, but there are a lot more. If you go to Kickstarter, for instance, you will find a lot of platforms that you can grab and start to develop on it. This is one of the most important things, I guess, from where we should start. Why? Because, well, in fact, the device itself is not going to be equal to Arduino platform or to ESP or to Raspberry Pi. Why? Because this is not cost effective. But for the proof of concept, this is the most important platforms that you can choose, because they already have a lot of things done and you just have to program and do something on top of it. And this reduces the time of the prototype, the proof of concept. And you should, as soon as possible, have something that you can show, that you can test, that you can give someone to test without being you. I can give you an example. A while back, we were asked to do some sensors to measure humidity on terrain, but not humidity that you usually think of on the floor, but 2 and 3 meters down. And we thought it was easy. We started to develop the prototypes, we put it up to test, and we found out a lot of things just because we put it to test. And that enabled us to quickly correct all the things that we found. And this is the most important, to have a prototype, to test it, to understand what is wrong, because something is going to be wrong for sure. Try it again, test it, try it again, try it again, and try it again. So you have to be as soon as possible with something done. The kits that we have here, you can buy it on everywhere, like in eBay, for instance, or other platforms, but they are the most basic stuff that you can buy now. The first one is Arduino based. Well, there's a lot of sensors and a lot of platforms that you can use. The second one is an ASP8266, and I will show you some examples that I have here. The third, Raspberry Pi 2 or 3 based. This one is a little more expensive, so you have to understand exactly what kind of prototype are you doing, because for the prototype it doesn't matter the cost, but when you put it onto production you have to look at it and understand that the cost of one is not the same as multiplying by 1,000,000, and so if you have success you have to sell it a lot and your margin will go smaller. Then we have the Raspberry Pi Zero. There's an option because it's a lot cheaper than the other, of course, with a lot of less power. Then we have, I chosen 2 other suppliers, Intel and Samsung, because they have 2 platforms that are ready that you can use to develop. So if you look at Arduino based, the Arduino family, we have a lot of things. You can look at the first one, the most known, Arduino Uno, and there's a interface that is called Arduino IDE that you can download from Arduino CC, and you can use to program this kind of device. In fact, you can use to program any of the devices that are here. And just to show you exactly what I mean, the IDE is this. It's not perfect, okay? It has a place where you code. It has some examples that you can use. For instance, you can come here to the examples, and you have a lot of examples. And you can try to understand the most simple ones. I can give you just an idea. Just for instance, this one, it's the blink one. It's the simplest thing that you have here. And you have just this one. So as you can see, this one is the most simple example of Arduino, and you have 2 methods that you have, the setup and then the loop. And this is pretty simple. Why? Because the setup only runs once when the device is powered on, and the loop is always continuously running. So everything that is here is going to run as fast as Arduino can. Every time when it stops, it starts again. So this one is a very simple example, And I can tell you what it does. It doesn't really matter to do it, but what it does is putting a LED on and off, because on the pin 13 that is here, it's a LED, a red LED that you have on the Arduino board. So if you do deploy, you will see it blinking every second because of the delay. So this is a pretty simple example. I have a more difficult example, this one that I'm going to show you in a while when I deploy it to another board that not Arduino, but this one is a little bit more complex, and what it does is uses the internet, the Wi-Fi, the local Wi-Fi to communicate and to send or receive information. Okay, so regarding the Arduino family, we have a lot of different ones, like this one, the Arduino Uno, and then you have the Yun. This one is pretty cool because it has Wi-Fi integrated on it. And these ones are sewable. It means that are usually used on clothes. That's why they have this form, because you can sew it to the jacket, for instance. And with a little battery, you can have it for a long time on a jacket. For instance, there's a cool thing that is used for bikers to show where they want to turn to with the yellow light. And this one of the examples that is on the internet is using this one. So it has two buttons and clicks left or right, and it shows on a on a yellow LED on the back of the jacket if you want to turn left or right. Then you have a lot smaller here, the Nano with the Pro Mini and the Mini. These ones are a lot smaller, okay, and the Micro. And these ones are, for instance, if you need for them to be small, because you want to put him on a box or you want to put it on something that these ones don't fit. Of course, these ones are more powerful. This one has a better CPU, has a lot of more pins, so you can control more stuff. But in these ones that you have here, you can choose and use whatever you want. Just a reminder, if you want to use this one, the best thing to start is go to Arduino CC, as I was telling you, and you can get all the information regarding this kind of platform. So this is the place where you start, and from here you can get all the information. Just a reminder, this was called Arduino on all over the world, but a year ago I think they changed outside of the US for Genuino just because of branding purpose, but in fact it's the same thing and the devices are the same. These devices are also open source. The schematics are open, so you can get information about these schematics and do your own. And if in prototyping it's not important, but when you look at doing the product itself, it's important, because you can take parts of the things that you have here and use it on another device. I will show you an example afterwards of something that was done like this. Okay. After the Arduino family, and Arduino was the first thing that we used when we start on IoT, we looked at the ISP8266 family. And this thing, it's more or less like an Arduino. In fact, you can use exactly the same IDE to program it. Okay, and what you can do with it is it has already built-in Wi-Fi, so you don't have to put or to buy a Yun or to put one ASP in Arduino. You just have to buy this one and then program it. It's a little bit harder to do. Why? Because it has a lot of less pins, so you don't have all the functionality that you have on the others, and because they are a lot smaller. Okay, when I say smaller, I can show you right now, but this one, oops, wait. Uh-oh. Just wait a little bit. Okay, we are back again. And I was telling you that I was going to show you with the camera. So as you can see, this one is an ASP. It's a 12 model. Okay, so it's a lot smaller than, for instance, this is the Micro. or the Nano, and you can see it's a lot bigger. And of course the Arduino Uno compared with this one. So this one's a lot smaller, but of course you have to be good with an iron solder in order to make it usable, because you have to work on it in order to connect the pins. But this one is pretty small, as you can see, compared with those two over there. Okay? So these ones are great. Why? Because they have the capability of connecting to the Wi-Fi, and they're a lot cheaper because they don't have all the things that Arduino needs. And an Arduino, in order to have Wi-Fi, has to have one of those connected to it. And the things that I don't like on it, it's the power they use. They need a lot more power than the Arduino. Why? Because of the Wi-Fi. And if you're trying to use these ones, you better have a charger that supports at least 2 amps. It's not because they need 2 amps, but on the boot process, it gives a little spike, and sometimes the charger cannot deliver the correct amount of power, and then it crashes. So you think it's your code, and it's not. The code has no problem. The problem is with the charger that cannot give the full power that it needs. I have like here 11 versions, but as you can see, there's a 12th, that's the one that I used. And now there is an ASP826632 that has a lot more power than these ones. You can get one of these for €3 on eBay, for instance. Of course, this is good for prototyping. If you need to do a lot more than this, you can do one thing that I'm going to show you afterwards, but you will need to build your own PCB and put it on the PCB, okay? So, regarding ASP8266, if you want to use it, you can use the same IDE, like I have it here, but you have examples specific for it. As you can see, if I come here, you will see some ASP8266 samples. The web server, the Wi-Fi mesh, and so on. So, if you want to use it, you can use one of those samples. This is one of the samples that I have. And you just have, on this case, to put the Wi-Fi information, like the SSID and the password, in order to connect. But there's a little trick that you have to do also, because there's a pin that has to be connected in a specific way. You can get that information online. But if you have something like this that I have here, that is called a node MCU, you have a pin here that you can connect and disconnect and connect. Okay, so every time you have to upload the code, you have to use this pin and click it and then do the upload. I can show you exactly what I mean. Just disconnect from here, and then you connect it with the click on the pin. You wait a little bit, and then you disconnect the pin. So the pin is working, and the ASP is also waiting for the boot. So if I now try to boot, to upload the code, it will upload the code to the ASP, and then we'll start to try to connect to the wireless network. Just wait a little bit, it's compiling, it takes a little bit. This is not perfect yet. I told you previously that you had better IDE to develop. Okay, this is better. Imagine the others that we had previously. So it's rebuilding, and now it will start to upload. And if I'm lucky, we'll see the upload on the bottom with the percentage. As this code is very small, it takes like 30 seconds to do. Let me check. Okay, it's trying to upload. It failed. Well, just remove it again, press it, click it, and then start again to do the same thing. And I will move it now and wait. and I can show you the code. It's not very hard to understand. You have the same setup as the Arduino has, and you have the same loop. And what it does is, on the setup, it tries to connect to the wireless, and if it can, you will say, I'm connected. And then on the loop, you wait for a client to ask for something. Of course, the ask for something is here. Okay, he's looking at exactly what I'm putting on the browser and try to understand it, if it's a 0 or a 1, and do something with it. This is pretty simple example, but here you can code exactly what you want. For instance, I'm going to show you afterwards something we did getting an ASP and some other components in order to control the light, right? Just a little bit, I will show you again, just to make sure it works. Okay, it's connected. I will try it again. If not, I will show you a little bit afterwards. So this is the ASP, and I was telling you the advantage is smaller, faster, and cheaper than buying an Arduino with Wi-Fi also. So this is now what almost everybody uses for prototyping everything that needs to be connected to Wi-Fi. Of course, if you need to be connected to GSM or other things that I'm going to discuss after next slides, you have to buy the appropriate things in order to communicate with those protocols. For instance, Sigfox or LoRa or something like it. Just waiting for it. Okay, as you see, it's now uploading. So it's uploading this code to the ASP, in this case a Node MCU. And we use this one because it's easier, has all the pins soldered and all the other things that we need in order to connect them to USB. So 100% it's connected, and if you go to our monitor, you will see that it's trying to connect to my network. It connected, and now it has an IP, so now I can open it on the browser and look at it and try to do 192.168.0.101, and now he asks for GPIO 0, okay, and he will give you exactly the indication that he tried to do it. It disconnected and he put the GPIO in low. This means that this pin is off, so if it had information, for instance, to connect a light, the light will be off, and if you do this, the same thing, it will be high, meaning that you've already connected the light. So this is a very simple example, that one thing that you connect through Wi-Fi and put it on your network in order to control something, okay? Another thing that you can use is the Raspberry Pi family, and you have at least 3 models for the Pi, okay? In fact, there are more, but the first ones are a version of the first, then the second, and this one is the third. The third is the last version, and I use this one mainly because we bought it, the third version, but because it can use the IoT core from Microsoft. So you can use Linux, for instance, installing on this Raspberry Pis, but also you can use Microsoft Windows 10 IoT core, and you can deploy it here, and you can use it as an operating system, and you can deploy applications for there. I like it a lot. Why? Because of the universal app that you can, the app platform that you can use, that you can almost have the same code in all of the devices. Of course, it's not exactly the same, for instance, because here you have pins, GPIOs to connect to. On a phone you don't have. And on a phone you have a screen, and here you don't have it, at least if you buy only the Raspberry Pi. So they are a little bit different, but most of the code you can use. That's a pretty good thing when you develop for multiple platforms. Another one that I like a lot is this one. This is the most unknown Raspberry Pi. It's Pi 0. And in this one you cannot put IoT core, it's too small. But you can put a Linux distro, and you can use it to make the same as Arduino. This one has no Wi-Fi, so it has the same problem as the Arduino has if you need communication, but it has the HDMI interface, so you can connect it to a TV, and you have also the USB connection, so you can connect it to other things. The good thing about this is this costs around $5 or £6 if you buy it on UK, so it's a lot cheaper than the normal Raspberry Pi. It's a lot cheaper, less powerful, doesn't support IoT Core, but you can use it as the end of the sensor. So you can connect sensors here and then send it to the Raspberry Pi to process and to send to another place. So it's a good way to do it. If you want to have lots of sensors connected, you can do a mesh network where some of the things are Arduinos or ASPs and some of the things are Raspberry Pis. Why? Well, because of security mainly. Because the ASPs and the Arduinos are very difficult to have secured ones, because they have so much space, so less space to put code that you cannot put everything there. But on the other hand, you can use the Raspberry those capabilities in order to secure, and then secure all the sensors and all the Arduinos that are connected on the back end of this. Okay. This is the pinout that you have for Raspberry Pi 2 and 3. As you can see, you can have like 24, if I'm not mistaken, different controllers. And we are doing some tests on one to control 24 different relays in order to control 24 different power. So I can control 24 different lamps, 24 different devices, 24 or a combination between of those. I will show you that as a last demo, but you can do it easily if you look at the code. It's like pretty simple if you want to implement it yourself. Another option that you have is use Intel platform. Intel has at least two platforms, two devices that you can use. The Galileo, that is smaller, is compared to an Arduino in terms of performance, and the Edison, that is a lot bigger. It's more or less like a small computer, and has the capability of a low-end computer. The Edison is pretty cool if you want to have a lot of capability for processing. For instance, if you want to have a camera connected, could be a good choice. The Raspberry Pi is also a good choice, but this one has more power, so it's better. The Galileo is more connected to the Arduino. As you can see also, this is one of the major players on hardware in the world and is deeply engaged on IoT. Another one of those is Samsung. Samsung has an end-to-end platform, but on the device side it has this Arctic 1, 5 and 10, and depending what you need you can choose which one of those. I think commercially available it's always only the one that is available, but at least it was a couple of months ago, and you can choose regarding the capabilities that you need, what you need to use. And for instance, the one, it's very low power, it uses BLE as communication and doesn't have any other chance to do it other way. On the other two, the Arctic 5 and 10, you can choose Wi-Fi, Bluetooth, BLE, Zigbee, so you have a lot of choices in order to implement communication. So these platforms that we saw are platforms that you can choose regardless of the project that you want to develop. But if you want to develop something that is a little bit higher level, you can choose platforms that are already designed for it. For instance, in Portugal, we have a manufacturer for Vitalino, and if you want to develop prototypes that are connected with medical, for instance, measuring biosignals, you can use already their platform to try to do it faster, because they already have the sensors, they already have all the hardware that you need. You just have to code it in order to give the exact thing that you want. The PCB that you see on the right is exactly all the sensors that they have connected to a power and to a communications model. So if you need, it's always everything done. But if you look at Kickstarter, you will find a lot of other kits. For instance, this one, and it's now on Kickstarter, has all the sensors and you can connect it easily, and rapidly put something to work. And this is very important because the most important thing on this part that we are is to have something that you can use to test it, to understand if it works, to understand if you want to do it like that, and afterwards you will produce exactly the hardware that you need. This one is just for proof of concept. Okay, but after this phase where we try to do the proof of concept, try to put a device to work, after that we put our stage in pre-production. So what we need to do is try to understand the errors, to refine it, and try to develop the PCB layout in order to have the golden samples. The golden samples are the ones that I was telling you, that it's the first thing that you deliver, and the main point of it is to get feedback about the usage and to get feedback about what the things that are not going to work, because for sure it happens all the time. You have to test it, and this is the best test that you can have. Put it on the hands of people that are users, not the guys that develop it. So here you get quotes from factories or from manufacturers to get the PCBs. And the best thing that you have to be careful here, the thing that you have to look for, is to have fast development of PCBs. Why? Well, because if it takes too long, like you send it to China, it takes, like, imagine 4 weeks to come, the cycle is very big. So it's better to work with a local producer because it's a small amount. You're going to pay a lot of money for each, but as like 10, 20, 40, 100 at max, you don't have the problem of paying a lot, and they can deliver it to you faster because they are near you, and they can work with you, and you can call them, and you can go there, and you can see exactly what they are developing. So this is a very good way to work with local manufacturers to get this right. And after this, you go to production, if you're lucky, if everything is running smoothly. And what you do usually here, you look for price and quality. So you try to find manufacturers that can produce and burn the firmware and test it to make sure it's good, and to put it on a package if you are able to do that. But you have to look for someone that does this with quality and the best price that you can. So usually, and nowadays, everything that you do, it's made on China, so probably we'll find a manufacturer there in order to use them. If you can, test it before. Choose 2, 3, 4, make them to do small versions, like 10, 20 or something like it. Send it back, look at it, test it, understand the quality, and then ask the supplier for more quantity, because it's the best way to understand exactly how they can produce the quality that they can produce and how for you. And after that, you have the runtime. And the runtime, it's when everything is selling and you're just looking for the bugs and the upgrades that you need to do to your software. And here you can have 3 things that you have to look for. The analytics for the data that your customers are using, to understand how the customers are using your product. The update center for the SDKs and the firmware that you want to download and upgrade the device. For instance, I have a light bulb at the office that is continuously upgrading the firmware. Why? Because they are understanding that they have some problems with it, and they are correcting it, and automatically it downloads the software and install it again. This is pretty good, because or else I will be exposed to security flaws, for instance, and it's not good to have it on things that you have at your office or at your home. And then you build a security center to help provide hardware and software-based security in order to keep improving the product. This is one of the things that I would like to reference also. You have to build on your product a way of doing the firmware upgrade, and over-the-air is usually the best choice. So usually you should use over-the-air upgrades in order to keep it simple to the user, and you have to put that on the product, so you have to have code on the firmware to do it. And for instance, for ASPs and Arduinos, there's already people that have done it. You can find it on GitHub, for instance, and you have that problem also solved. Okay, so I understand that we already have covered the steps, we already have covered the definition, the platform, so we have already talked about it. But how about the challenges? I'm starting to develop things on IoT. What are the challenges? Well, there are a lot of challenges. For instance, if you look at the ones that I have here, privacy. Well, I put a device on my house. It's supposed to monitor my baby for me to understand when he's crying or sleeping. Well, it's a camera, it's a microphone, so it listens 24 hours in my house. So if it has a flaw, it can send information outside and people can see things that's not supposed to see in my house. So, as security, well, they can have, for instance, a friend of mine has the capability of opening the doors from his house remotely. Great! He can open it when the housekeeper forgets the key, but also if someone can connect to it, he can open it without him knowing and can take anything from there. Then interop. Well, great, I have a light that I want to use. This is pretty cool. And I have a button that I bought from Amazon and I want to be able with the button to disconnect the light. Well, now there's a lot of work to be done in this area because a lot of things cannot communicate. Another thing, it's data. Well, great, I have a sensor. It generates 10Ks of information. Imagine if I have 2 million sensors, 3 million. So where do I going to store that information? Then reliability. Well, when it's broken, we'll fix it. And how? I sold it to China or to India and I'm in Portugal. How the hell am I going to solve the problem? I'm going to send a new one. I'm going to ask for the other one. I have to have a channel. I have to have people in all those countries to solve the problems. So this is a very important problem. And probably it's going to be a place where we have to improve a lot. Then communications. Well, I have to communicate to the cloud. How? It's too expensive, it's not expensive, I'm going to use Wi-Fi, what I'm going to use. And the last one that I consider is power. Well, I have to put power on my device. I can connect it to a plug, but it's going to be mobile on a bicycle, so I have to have batteries or solar or other ways of producing energy. In fact, we have a lot of things that we have to improve here. So if you look at detail of each one of those, the privacy. Regarding privacy, we have a lot of problems that you have to address. Identification, for instance, who uses the devices. If we are open to understanding who is the person that is using the device, we can get the profile about it. Then, tracking and routes. Where are you at the time and where? So you can get information about everything that you've done. Your phone is doing this right now, so it's a problem. I recently found out my phone was keeping track of me all the time, and I can saw it on the map every place where I was. Not good to understand it afterwards. Then profile creation. I don't know that is you, but I know that someone came here 10 times, and other person came with him, and these two persons were here and were seeing a football match and also at some restaurants, so I can create patterns of usage. And connection between users, more or less the same as profile creation. I can get which users were at the same time and where, how they are connected. Are they friends because they are at the same time? Are they have the same likes? They use the same things? They do the same sports? And afterwards, another thing that you have to be careful is, I have a device that I sell to another person. Well, the information that was stored is what happens to it. It's deleted, it's changing to the new user can get that information. On phones we have more or less that resolved. We do an hard reset and all the information goes. But on most of the IoT things this doesn't happen. The account, it's not possible to change from user to user. If you look at security, you have the same problem, or the same challenges, if you will. There's a lot of security flaws. For instance, one of the switches that was most sold on the internet had a problem that we can connect to it from outside because the password was easily breakable because of the algorithm that it was using, and all the other information was sent in plain text, so it was easy. The same thing regarding the LiftX bulb that I use. you can do a series of trying to connect to the lamp, and she will reboot herself, and afterwards we can create a Wi-Fi receiver that emulates the lamp in order to people to connect to it and get the information from their phones, for instance. Another of the problems that I was telling you, the interoperability problem. I had a dream when I worked in Microsoft that had one remote to control everything that I had at home. But the reality now, I have 3 remotes, 4 remotes, 5. It doesn't really matter. It depends on the number of devices that you have. And this is going to be one of the problems that we're going to have also in IoT. Because every ISV, every iOS, every system that is developed, including by me, has different protocols and different way of communicating. So every time I want to connect a lamp to a phone or to something else, like a thermometer, for instance, I have to make something in order to be able to connect. There are some initiatives that are working now and trying to solve these problems, like the All Scene Alliance. Microsoft is on this one, for instance. And it's an open source framework that allows devices to communicate. So if you use that protocol, they use the same kind of APIs in order for them to connect. This is a very good initiative in order to put every IoT device on the same level, be able to communicate for the user to get the most value. Another initiative that is more communication than API, for instance, is the Zigbee Alliance. It also has a Wi-Fi based protocol that enables devices to communicate the same way. There are a lot of things like MQTT that is a protocol in order to be able to communicate between devices. If you want to understand all the protocols, or at least the most important, you can go to this link, the postcapes.com, Internet of Things protocols, and get the information about all the protocols that are used nowadays on IoT. Another of the challenges is the data. Why? Because of the number of devices. If you do a simple math and one device stores 1 KB per hour of information, and you multiply it by 24 hours for 365 days, you will get at the end, if you multiply it by 8 million devices, 8,354 terabytes of information. That's a lot. And nowadays it's pretty difficult to have a data center that can store that information. So data has a lot of problems. The storage capability, the easy to manipulate data, the data security, the availability, all of these are things that you have to look for when you have IoT. Of course, one of the solutions is cloud providers. There's a lot of cloud providers that can solve these problems because they are done for scale, for big solutions like the Microsoft Azure IoT Suite, or the Intel IoT, or the Samsung Arctic, or even the Google Cloud Platform or the Amazon IoT. So you have a lot of solutions that you can use. For me, of course, because I'm used to it, I prefer to use the Microsoft Azure IoT Suite because I know the APIs and I know how to work with them. But just choose one because of your preferences, because of the price, because of the things that you need, and try to understand exactly what you can do with it. Afterwards, you have communications, another of the challenges, the cost, the coverage, and the power consumed. Well, you have the cost because, well, every time it costs money, it has to cost money to someone, to the guy that does it or to the user. So everybody that looks at it wants to understand exactly how it's going to pay in order to have the right idea how much it's going to cost on the long term. Other thing important is coverage, where I'm going to use it. And the most important thing is power consumed. Why? Because you have a device that's supposed to last for 10 hours and it lasts 1, the consumer is not going to be happy. Regarding communications, you have a lot of possible solutions. For instance, Sigfox and LoRa, 2 low power protocols that you can use with a very big range that you can communicate. For instance, Sigfox is, I guess, like 98% of the people in Portugal, but is a solution that is widely available in Europe. Lore is more or less the same thing, but is an open source initiative. So you can use more or less the same things as Sigfox, but it's an infrastructure that you have to do yourself. And then you have the traditional one, GSM, Wi-Fi, Bluetooth, and then you have Zigbee. As I was telling you, it's a very used protocol in order to enable communications, and then radio that you can use on the free frequencies or the paid ones, it depends, and put your own network in place. It always depends of the thing that you're going to do and the price that you're willing to pay. Okay. And one of the last things is reliability. Okay, it's great. I bought something to put in my house, but when it's broken, what do? I throw it away. Who fixes it? Can I send it to somewhere? How much time do I going to spend without it? How do I do firmware upgrades? It's easy. It's just doing nothing. Or do I have to put a new USB pen, or I can't? How do you ensure usage conditions? Well, I say that my device only can be used when it's not raining, but how can I control? How can I really understand what's happening? And how to return it if needed? How do I get the device to me? For instance, one of the things that happened with the device that I used, they had a lot of problems on the beginning. They keep sending me new ones, and I was keeping returning the old ones. Of course, after a while, they were not making any money with me. In fact, they were having loss. So this is very important, and that's why testing is very important to do. Okay. And the last one, power. So if you look at the way that your device is going to be used, you have to understand what kind of power do you want to have. You can have solar, for instance, and this is one of the cheapest ones. You can be connected to the grid, the power grid, connected to a plug, and if it's for home, probably it's good enough. You can have self-generating. You can produce your own energy. For instance, there I have a button that you can click, and the click on the button produces energy to communicate with the devices. So it doesn't need battery, or it can be battery powered. So you have to understand exactly what kind of the things that you want to use in order to understand what is the best solution to you. Okay, and I have two more examples that I want to show to you because we have time. One is the Raspberry Pi 3 with universal apps in order to control the relays that I was telling you, and another one is the finished product of some assembled components that we made, and I can tell you and show you exactly the components that were used. And I'm going to start by that one, and I'm going to show you this one. So this one that you have here is, as you can now see, it has an ASP here, and then has two relays to control two different lights or two different sets of lights. So if you look at this one, and I'm going to put it here, and I'm going to grab the ASP and put it here. So this is this. I'm going to grab the charger that translates from 220 to 3.3 or 5, it depends. And as you can see, this is this. And then I'm going to grab a relay, and this is this. So if you buy separate components and assemble it on the PCB, you can have pretty easily exactly the same thing that I have. Okay, just need two of those, one of this, and the PCB in red and the code. Okay, so this is a way of rapidly combining and making a golden sample. After the prototype that you can do using these ones, you can use and produce several of these. It's a lot cheaper because you don't have to solder a lot of things, and the PCB is pretty simple, and you connect it. After this, when you go to production, you have all the components in the same PCB, and you have everything a lot cheaper. This is why this is the two stages before production, and then you will have the other afterwards. Another thing that I can show you is the Pi Zero, as you can see here. This is the Pi Zero. It's a lot smaller than the Pi 3, and it's a lot simpler also. And you can solder here the connectors in order to control the GPIOs. Okay? And now this is the one that I want to show you. So as you can see, I have a Raspberry Pi a 3 version here connected to my wireless, and then I have 8 relays where I can control all the lighting at my house. I can control 24 lights. So if I do this, I can disconnect it all and I can connect them all. Okay. Of course, I cannot do it all at the same time because I can want to keep one light connected and the others off. So I built something on my HTTP server that I put it there. I'm going to show you the code afterwards. That I could call in the very simplest way, like the number of the pin and on and off, considering that I want to disconnect it or connect it. Okay, as you can see, I'm going to show you now. I just disconnected this one. Okay, the last one, as you can see, it's off. Okay, but if I change it to on and then change it again, you can see that it's on now. So it's pretty simple. It's just a demo for you to understand exactly what it is, but I'm going to show you the code that is used to produce this. So it's Visual Studio solution. It's a pretty simple solution. I'm sorry for the code. I hard-coded the pins. Okay, so these are the usable pins of the Raspberry Pi. And then what I do is I connect them all and put it on when I'm starting. And then I have the web server, and here I split the URL and get the device that I want to connect and the state that I want to connect, and if it's on or off, I will put it to low or to high, meaning that I can disconnect it and connect it. To deploy, it's pretty simple. I just have to do this, and this deploys it to the Wi-Fi, to the Raspberry Pi, and I will use it afterwards. So I just have to wait a little bit because it's starting to deploy. It will start the application and it will enable me to use the device to do what I was doing. So it's pretty simple. It took me one morning to put it all together. Okay, so as you can see, it's on already. Okay, so all of them are on, and now I can use it through the browser. Okay, so that's about everything that I have to show you. In conclusion, I hope everything that I've shown you could get you starting on IoT. And the most important thing for me is to try to pass along the message that you can use all these platforms to prototype. You can use them even to produce your golden samples, but of course it's cheaper and better afterwards to design your PCBs and to have them on production, a different thing. This is only for testing, prototyping, nothing more than that, because it's fast. And I hope I will also show you the problems and the challenge that you have regarding those kind of solutions on IoT. I was telling you about interoperability, reliability, data, communications, power, so security, all of those things that are important, and you have to build it in on the product in order for people to buy it without concerns. And okay, that's about everything. You just have to have good ideas and start the process. If you need anything, just ask. But I thank you for being here and for watching it. And if you need more, or if you want to listen to more the upcoming masterclasses, here's the link that you have to follow in order to see them, because they're all pretty interesting.